Okay, so today we're going to look at the product of matrices. This is where we have a matrix multiplied with another matrix. So that's doing like this. So we're going to have a matrix multiplied with the other. The other day we did scalar multiplication. That's just when we had a number outside and we multiplied everything inside. So today we're going to look at when we multiply a matrix with another matrix. Now, to be able to do this, there has to be some conditions that fit, and it's the conditions to do with their orders. So remember that their orders are how many rows and columns they have. So if you look here, I've put down here, I've got matrix A, and it's got an order of whatever it would be. So say, for example, I might say matrix A is a 2 by 3, okay? And then we look at, it's going to be multiplied with, say, matrix B, and I'm going to say matrix B has a 2 by 4 order. Okay, so if this is possible, so for you to be able to multiply any two matrices with each other, what you have to see is that the number of columns, can you see there? The number of columns in the first matrix has to equal the number of rows in the second. So can you see I can multiply my little example because the columns are 2 in the first one and the rows are 2 in the second, okay? So for you to be able to do it, that has to be there. That has to be able to, if they don't match, if they're not like that, you can't multiply them. So once you can say, yes, we can multiply because these two numbers are the same. So I'm going to go yes because they are the same. I can multiply it. You end up multiplying, and I'll show you how to do that in a minute. But what happens is you end up with this matrix over here. Sometimes we can call it a different letter. Sometimes they call it like matrix AB because you've multiplied A and B together. And what it ends up is with an order, it will have the number of rows that the first one had, and it'll have the number of columns that the second one had. So in my example, if I multiplied those two matrices, my answer is going to be a 3 by 4. Can you see that? Because it's 3 there and 4 there. Okay? So often they ask you, is matrix multiplication possible? So they might say, can you multiply these two together? If they ask you that, you have to write this statement. You've got it in your notes. Write it exactly how it is written there, okay? So if I was to say, can I multiply A with B? I'd say, yes, I can, because the number of columns in the first matrix equals the number of rows in the second matrix. Okay, so that's the statement you have to say, those exact words, if you're asked, is it possible? All right. All right, so if we have a look, let's have a look down here. So at the moment, we're just looking at is it possible to be able to multiply them? All right, so if you look at A, what's A's order here? What type of order is A? How many rows has it got?
2.
And how many columns has it got?
3.
Good. What's B's order here? No, how many rows first? Remember rows before?
1.
Yeah. So 3, 1, and this one?
2.
Good, 2 by 2. So what we can see, if I was going to multiply matrix A in this scenario by matrix B, I would look, I've got a 2 by 3 and a 3 by 1. I can multiply them because those numbers equal. So the number of columns in that first matrix is equal to the number of rows, so I can multiply it. And when I do, my answer, so say whatever it ends up being, my answer is going to have an order of 2 and 1. Okay, so it's going to be a 2 by 1. All right, let's test though. If I go, and watch this, if I change it to B being the first one and A being the second one, you can see I've got a 3 by 1 and a 2 by 3, well, this is not even possible, is it? They do not equal, so not possible. So we just say it's not possible to multiply them. Your calculator will say undefined, yeah? You can't do it. So that one is undefined. So can you see order is extremely important on which one goes first for matrices? Because in normal maths, we can say 2 times 3 is the same as 3 times 2, isn't it? Yeah, but it's not in matrices. So order becomes very important in terms of which one you need to put first, so be careful with that. So if they can be multiplied, we'll often see the words it's defined. That matrix multiplication is defined. If it's not equal, they'll say is undefined. All right, so let's have a look at some. This is summarizing now the general rule. So in general, if you want to be able to multiply them, the columns of the first matrix must equal the rows in the second, okay? So these must equal, okay? Once you do that, you get an order of this one, the rows of the first, and the columns of the second. So I'm just summarizing the rule there to help you. So this will be the new matrix size, or you might want to say the new matrix order, because we call it order. All right, so let's have a look at these little examples. It says, which of the following are defined, and if they are, what is the order if we multiply them? So if we go and have a look, if you look up here, let's just put the orders underneath. A is a 2 by 2, B is a 1 by 2, and C is a 2 by 1. So can A be multiplied with B? And if you look here, I've put the order of A and the order of the B. They are not equal, so it's not defined. So I can't, so that's it. I just showed not defined. If you look at B times A, so this was B and this was A, they are equal, so it is defined, and you can see the order is going to be a 1 by 2, which I've put there. 1 by 2, yeah? If we look at this one is C, this one is B, is this one defined? Yes. So yes, it's defined, and the order is going to be a 1 by 2. So you can see there, they've created the order, a 1 by 2. And then the last one, they've put C first and A second. Yes, it's defined, and the order will be a 1 by 2. Oh, that's not right, is it? So we're going to cross that out. Is C because you know why? C is not a 1 by 2, is it? C is a 2 by 1. We've written that wrong down, so that's not defined. Okay. All right, now so we've done whether we can do it and what will the answer be when it is done. So now we're going to show you how to multiply two matrices, and what I'm showing you now is the manual way. Okay, so we need to know how to do it without the calculator, and we'll only ever do the manual way for small matrices. They won't be any bigger than a 2 by 2 really, okay? So you only really have to do a couple of lines, so you don't need to worry too much. When they get really big, we do them on our calculator. But I'm going to show you how to do them anyway. Alright, so when we multiply a matrix, we multiply each row with each column as shown. So what's going to happen is these numbers A and B will get multiplied with E and G. Okay, now let's have a look though. Let's look at first the orders. See if this was matrix, this is the first matrix. It is a 2 by 2 and this one's also 2 by 2. So what you're going to say is yes, it's defined, and my answer is going to be a 2 by 2, isn't it? Yeah? So what I'm just going to draw it out a little bit bigger over here, because this is probably how I would do it. So I work out what my answer is, and it's going to be a 2 by 2. So what I do lightly, I put little boxes of the elements I've got to have. So I've got to have an answer for elements, don't I? Can you see that? So that's what I look at. So then when I look over here in this answer one, this box here, if you look here, this box here is in row 1, column 1. Would you agree? Yes? So it's row 1, column 1. So that is the letters, or that's the spot I'm going to use in my other two matrix. So can you see I'm using row 1 here and column 1 there. So what gets happened is this A gets multiplied with E and this B gets multiplied with G, and then you add them together. So that's why you're seeing this here, A and E times together plus B and G, and that gives this answer in here. So that's where AE plus BG goes in there. Alright, so if I was going to do this box here, I know that this is in row 1, column 2. So the ones I would be using for it, sorry, I'm just going to rub that out. I'm recording it, so don't stress. So I'm going to use that one. I'm in row 1, so I'm going to use row 1 with column 2. So can you see that's why I'm going A with the F and the second one with the second one. So it gets up being AF plus B H in there. Alright, so then if I do this one here, can you see I'm actually in row 2, column 1? So I would be using row 2, column 1 to get my answer. Alright, and they match up. And there it is. And then so long if I did this last one over here, I'm in row 2, column 2. So what I would be using is row 2, column 2 to get my answer. So you can see that's what they're doing there. And they're adding it into that one. Alright, so we're going to do some examples. We're going to try multiplying this matrix A by this matrix B. So first I'm going to do is check. It's a 1 by 3 with a 3 by 1. So is it defined? Yes, it's defined because the number of columns in the first equals the number of rows. Now I look at my answer and I know it's going to be a what? A 1 by 1. So what I'm going to do is I'm going to draw up a matrix and I'm going to put the one, it'd be just one element, wouldn't it? Yes? So that's okay. So I've done that. Now I'm going to, so really this is, sorry, change the pen. This is row 1, column 1. So I'm going to multiply this with this. So what I'm going to have is this 1 gets multiplied with 2. Then I plus this 2 multiplied with what? 4, good. Plus this 3 multiplied with 1. So then you just tidy it up, keep tidying it up. So really 1 times 2 is 2, 2 times 4 is 8, and 3 times 1 is 3. And then I can add those numbers, so it ends up with 13. And that is a 1 by 1, isn't it? Yeah? Okay, I'm doing the next one. So A is a 2 by 2 and B is a 2 by 1. Is it defined? Yes, it is. And what will its order be? It'll be a 2 by 1. Good. So I'm going to draw up that, and I just 2 rows, 1 column. So I'm just putting a little spot in there just so I know that I know how many elements I need to have in there. Alright, so if I'm going to this first one, I'm in row 1, column 1. So that means I'm going to row 1 is going to get multiplied with column 1 in the second one. So it is 1 times 2 plus 0 times 3. And now this next one down here, I'm in row 2, column 2. So column what? 1? There's only one column, isn't it? So I'm going to go row 2 with column 1. So this one will be 2 by 2 plus 3 by 3. So then just tidy all that up. It's actually 2 plus 0 and 4 plus 9. So I can still add them. So I've got 2 plus and 13. And I double check, that's a 2 by 1. That's what I wanted. Alright, this last one, so we've got a 2 by 2. Doesn't matter that there's letters there. We'll just leave it. It's still a matrix. And this is a 2 by 1. So is it defined? Yes. And what will my answer be? A 2 by 1. Awesome. So I'm going to draw that out. And I've got 2 rows and 1 column. Alright, so I'm going in here. I'm going to do that answer in that. That's row 1, column 1. So it'll be row 1 with column 1. All I'm going to do is exactly the same. It's 1 times x plus 3 times y. Okay, and then I'm going to do this element in here. And I can see that element is in row 2, column 1. So that means I do row 2, column 1. And it'll be 2 times x plus negative 4 times y. Alright, we're going to tidy this up now. So 1 times x is x plus 3y. 3 times y. Then I've got 2 times x is 2x plus negative 4 times y, which would end up being minus 4y. You can write plus minus, but we don't normally have to. Now, can I add x and y's together? No, so it just stays like that, where this is actually an element and that's an element, okay? You can't add them, you just leave it and that's it. It's done, okay?